Ever since ChatGPT released, developers have been on the fence, with every single AI CEO saying that developers will no longer be needed. How pleasant it is hearing that most of these tools that wants to get rid of developers are doomed for failure themselves. It seems like the AI bubble is about to pop. First, Apple released a paper suggesting that AI thinking is fluke and it isn't anything like a human thought process. Last week, MIT jumped a bombshell of a paper. 95% of all AI projects are doomed to fail. Does that mean that we should be worried about the 5% of the AI projects that might succeed? In my own humble opinion, developers should keep leveling up their coding, problem solving, and critical thinking skills to stand a chance against these evil tech CEOs. They have been telling us that artificial super intelligence is just by the corner, but they are still hiring developers like crazy, and they are also firing too. And in today's video, we are going to put AI to shame and build our first 2D game using HTML, CSS, and TypeScript. So make sure you stick around to the end to find out the amazing game we are going to build. You'll be surprised because it is going to give you a nostalgic feeling once you see it. In today's video, we build something useful, something fun, and highly interactive. So if that makes sense to you, then absolutely smash the like button. Ensure you subscribe to the channel and turn on the bell notification to get access to all of our videos as they drop. We will build on what we learned in our last video where I showed you guys how to build your own 2D physics engine. In that video, we saw how we could build a simple physics simulation using vectors. We saw how we could represent natural forces like gravity, friction, and air resistance, all using vectors. And in case you missed that video, you can find it on the channel. Once again, make sure you subscribe to the channel so you don't miss any of our videos, and you can also watch all of the videos that we've released in the past. So let's dive into the coding straight away. I will create an index HTML file, and inside it, I will just generate a blank HTML document using Emmet. I will change the title of the page to Brick Breaker. I will link to an external style sheet named index.css. This style sheet contains the styles for the game we are working on. I will add a canvas element with an ID of canvas. Then I will add a div element with an ID of game message and a class of game-message. I will add another div with an ID of score display and a class of score-display, and inside it I will nest a text score. I will add another div to the body of the document. It will have an ID of level display and a class of level-display, and inside it I will nest a text level 1. Then I will link to an external JavaScript page app.js. I'm going to create that index.css file, and I will add some styles to the body element. I will set the margin to be 0, the overflow will be hidden, the background color will be a hint of black, the font family will be inter/sans serif. I will set the display to flex, the flex direction will be column, and then I will justify the content to the center. I will align the items to the center and set the height to be 100 VH, that is 100% of the viewport height. I will target the canvas element and set the display to block. The border radius will be 12 pixels. I will add a box shadow to the canvas element. The background color will be white and the margin will be 0. I'm going to target the elements with the class of game-message. Then I will set its position to inherit from its parent element. I will set the top to be 10 pixels, the right to be 10 pixels, the color will be white, and the font size will be 1.5 rem, and then I will add a shadow to the text. I will target the element with a class of level display. I will set the position to be absolute, the top will be 10 pixels. I will set the left to be 10 pixels, the color will be white, the font size will be 1.5 rem, and I will add a shadow to the text. We will use TypeScript for today's video, just like as I said in the intro, and this is just to get a little bit of extra comfort while working. This video is a sequel to the first video where I showed you how to build your own 2D physics engine from scratch. Hope you didn't miss that one. Wait, don't tell me you did. Really? Okay, I'll suggest you hop on that video when you are done with this one. Just have to see it for yourself because there's nothing I'm going to tell you that's going to make mention of what we discussed in our last video. So I'm going to copy and paste in this vector class, and there's no need to go over it again. But for starters, this class allows us to create a 2D vector which will serve two purposes. First, it is going to define the state of objects in our simulation, and in this instance, since we are building a game, it is going to define the state of objects in the game. Two, this vector will act as forces that are acting upon the objects in our game. And once again, in our last video, I took my time to explain what vectors are, and I created this vector class in this video, showing you how each method works. So definitely go and check out that video if you don't understand what vectors are and how vectors work. Next, I will define the body class again due to some modifications, but I am going to quickly breeze through that, okay? Because we don't want to spend much time on that. Why? I've already implemented this body class in our last video, and once again, if you want to have a proper understanding of this body class or see me implement this body class from scratch, I'm going to suggest that you go back and watch our last video so you understand more of what this body class can do. Now, let's define a first property, which is a vector. On the body class, we are going to define a radius property, which is a number, and a static property, which is a boolean, but I incorrectly used the number type. You should take note of that. I will define a type property, which is a string, and then I will add a constructor function where I will accept the position argument, which is a vector. I will also accept the velocity argument, which describes the velocity of the body, and it will be a new empty vector. The mass of this body will be 1. I will also accept the restitution argument, which will be 0.7. I will also accept a color argument, which by default will be red. I will accept a shape argument, which by default will be circle. I will accept a width argument, which by default is 40. I will accept a height argument, which by default is 42. And then I'm going to add an apply force method to this body class. Once again, this method applies a force onto the body. I will also implement the update method on this body class. This update method updates the state of the body by changing the velocity of the body and the position of the body. I already took my in the last video to explain how this update method works on the body class, okay? So definitely check that out if you want to understand more on that. I'm going to add a draw method that will allow us to draw shapes onto the canvas, and this is going to be used for drawing geometric shapes to the game. Let's re-implement the PhysicsWorld class again, and this time I'm going to take my time to do all of that. First, I will add a bodies property, which is an array of bodies. Then I will add a constructor function, and inside this function I will accept a canvas argument, which is of type HTML canvas element. Then I will accept a gravity argument, which is a vector, and inside this function I will set these bodies to be an empty array. I will add an add body function, which accepts a body as an argument, and inside this method I will push the body into these bodies. Next, we need to start implementing methods on this class that are related to the game we are building. First, I will add a method to the PhysicsWorld class named clearBricks. And inside this method, I will remove all bodies whose type is brick from this bodies array. Then I will add an update method which accepts an argument, which is a number. And inside this method, I will loop through the bodies array, and for each body, I will apply a gravitational force on it. Then I will call body.update with the T. Then I will call this check collisions, and after that I will call this check wall collisions. We have already implemented the check wall collisions method in our last video, but for you new guys, this function allows us to handle objects in the game colliding with the wall, especially the ball in this instance. This is because the game we are building will require the ball to collide with the top, left, and right walls of the simulations. I will not spend my time showing you how I implemented this method because I've already done so in our last video, so definitely go and watch it. Now let's re-implement the check collisions method. I have also implemented this method before in our previous video, but I will have to re-implement it from scratch again because its functionality is a little bit different from what it did in our last video. This check collision method is going to be responsible for detecting when two objects in our game is going to collide, okay? Now, inside this method, I will retrieve all the bricks in the game first, and I'm going to store them in a variable bricks. I will also retrieve the ball and store it in a variable ball. Then I will retrieve the paddle from the game and store it in a variable paddle. Then I will check if the ball variable is null or if the paddle variable is null, and then I'm going to return prematurely from this function, effectively ending it. After that, I will create another variable paddleRect, which is an object literal. It will have an X property which is equal to the X component of the position of the paddle minus the width of the paddle divided by 2. It will have a Y property which is equal to the Y component of the position of the paddle minus the height of the paddle divided by 2. It is going to have a width property which is equal to the width of the paddle and a height property which is equal to the height of the paddle. Next, I will create another variable, ball circle, which is also equal to an object literal. It will have an x property, which is equal to the x component of the position of the ball. It will have a y property, which is equal to the y component of the position of the ball. And finally, it will have a radius property, which is equal to the radius of the ball. Then I will check if there is a collision by calling the checkCircleRectCollision method with the ball circle and paddle rect as arguments to it. I will store the results returned inside of a variable collision, and it is obvious that we need to implement the checkCircleRectCollision method. So let's go ahead and do that. This method will accept two arguments, ball circle and paddle rect, whose type matches the two object literals, ball circle and paddle rect, we just defined earlier. Inside this function, I will first calculate the closest x by obtaining the largest number from the paddle rect.x. Then the second argument will be calling the math.mean function with the ball circle.x and the paddle rect.x plus the paddle rect.width. Then I'm going to calculate the closest y with the paddle rect.y as the first argument. The second argument will be the result of calling the math.mean function with the ball circle.y as the first argument and the paddle rect.y plus the paddle rect.height as the second argument. Then I will calculate the x by subtracting the closest x from the ball circle.x. I will also calculate the y by subtracting the ball circle.y from the closest y. Then I will calculate the distance square by squaring the x, summed up with the result of squaring the y. I will check if there is a hit by checking if the distance square is less than or equal to the square of the radius of the ball. If there is a hit, then I will calculate the normal, which is done by creating a new vector. The s component of this vector will be the ball circle.x minus the closest x, while the y component of the vector will be the ball circle.y minus the closest y. Then I will change a call to the normalized method and return an object with a hit property, which is true, and a normal property, which is equal to the normal variable. If there is no hit, then I will return an object with only a hit property, which is false. Let's go back to the check collisions method. We will check if there is a hit on the collision, and if that is true, then I will retrieve the normal from the collision and calculate the relative velocity using the static sub method on the vector class with the velocity of the ball and the velocity of the paddle. I will calculate the velocity along normal using the static dot method on the vector with the relative velocity and the normal. Then I will check if the velocity along normal is less than 0, and if that is the case, I will do a vector subtraction on the velocity of the ball by scaling up the normal vector with a value of 2 multiplied by the velocity along normal multiplied by the restitution of the ball. We are done with this. Next, I will add a for loop that iterates through the bricks starting at the top till we get to the bottom. Then I will create a brick by retrieving the current brick we are iterating over via the index of that brick, and then I will create a brick rect variable with an x property which is equal to the x component of the position of the brick. It will also have a y property which is equal to the y component of the position of the brick. It will have a width property which is equal to the width of the brick. It will have a height property which is equal to the height of the brick. Then we will check if there is a collision using the checkCircleRectCollision method with the ball circle and the brick rect. Then I will check if there is a hit on the collision, and if that is the case, I will retrieve the normal from the collision.normal. I will also retrieve the relative velocity from the velocity of the ball. Then I will use the relative velocity and the normal to calculate the velocity along normal using the static dot method on the vector class. I will check if the velocity along normal is less than 0, and if so, I will call the sub method on the velocity of the ball with the normal scaled up to 2 multiplied by the velocity along normal multiplied by the restitution of the ball. I will set the score to plus equal 10. We will create the score variable shortly. Then I will retrieve the score display and set the text content to equal to the current score. Then I will remove the brick from the bodies array on the physics world by calling the splice method on this.bodies with the index of the brick and 1. Then I will retrieve the canvas elements using the document or get element by id method. Then I will create a ctx variable by calling canvas.getContext with 2D. Then I will retrieve the game message element using the document or get element by id method with the game message. I will create a variable game running which is equal to false. I will create another variable game over which is equal to false. I will create a variable launch requested which is equal to false. I will create a variable score which is equal to 0. I will create another variable current level which is equal to 1. I will create a variable max levels which is equal to 3. I will create another variable is level transitioning which is equal to false. Then I will create a function resize canvas, and inside this function I will set the height of the canvas to be the window to inner height multiplied by 0.9. I will also set the width of the canvas to be the window to inner width multiplied by 0.9. Then I will call the resize canvas function. I will attach an event listener to the window. Anytime the window is resized, I will call the resize canvas function. Then I will create a variable word, which is the result of instantiating the PhysicsWorld class with the canvas elements. Then I will create a ball by instantiating the body class, and I will set the type of the ball to be ball. I will push this ball into the word.bodies, and then I will create a paddle object using the body class. I will set paddle.isStatic to true, and the type of the body will be paddle. I will push the paddle into word.bodies, and then I will create a function create bricks which accepts an argument level, and inside this function I will create a variable brick width which is equal to 88. I will create another variable brick height which is equal to 20. I will add another variable brick padding which is equal to 10. I will create another variable brick offset top which is equal to 30, and then I will create a variable brick offset left which is equal to 30. I will create an array of colors which will store the color for each brick. Then I will create a variable layout which has no value for now. I will add a switch statement which checks the value of level, and if it is 1, we will set layout to be equal to a 2-dimensional array, that is an array of arrays. The outer array will contain 4 inner arrays, and each of the inner array will contain 4 values, the integer 1, and then I will break out of this case. For the default condition, the layout will also be a 2-dimensional array, but it will only contain 2 inner arrays this time, with each inner array containing 8 values, the number 1. Then I will create a variable numCols which is equal to the length of the first inner array in the layout. I will create another variable numRows which is equal to the length of the layout, and then I will create another variable horizontal offset which is equal to the canvas.width minus the result of multiplying the numCols by the brick width plus the numCols minus 1 multiplied by the brick padding and dividing the whole equation by 2. Then I will add a for loop that iterates through the numRows, and for each row I will loop through the numCols. Then I will calculate the brick X and the brick Y. After that, I will create a new brick, and the brick X and the brick Y will be the position of the new brick. Then I will set the type of the body to be brick. I will set brick.isStatic to be true, and then I will push the brick into the word.bodies array. I will add a new function start level, and inside of this function I will call the word.clearBricks function, and after that I will call the createBricks function with the current level. Then I will set the position of the ball. I will also set the velocity of the ball. I will set the position of the paddle. I will set game running to be equal to false. Then I will set is level transitioning to be equal to false. Then I will will get the level display element using the document.getElement by ID API. I will set the text content to display the current level. I will set the display of the game message to be none, and then I will add another function, reset game. And inside this function, I will set the score to be equal to 0. The current level will be 1. I will set the text content of the score display to display the score. I will set the word.bodies to be an empty array, and I will call word.addBody with the ball and word.addBody with the paddle. I will call the start level function and set game over to be equal to false, and then I will add an event listener function to the mouse down event on the canvas, and inside this function I will check if game running is false and game over is false, and set launch requested to be false. Otherwise, if game over is true, then I will call the reset game function. I will attach another event listener to the mouse move event on the canvas, and inside this function we are going to check if game running is false, and then I'm going to return prematurely from this function. Then I will get the mouse position by first calling the canvas.getBoundingClientRect method, and then I will calculate the x coordinates of the mouse by subtracting the events.clientX from the rect.left. Then I will update the x component of the position of the paddle with the x coordinate of the mouse we just calculated. What this does is to track the movement of the cursor horizontally and use that to update the position of the paddle. I will add another function, check win loss, and inside this function I will check if is level transitioning is true, and then I will return prematurely from the function. I will retrieve the amount of bricks remaining, and then I will check if the bricks remaining is equal to 0, and inside this if check I will check if the current level is less than the max levels and set is level transitioning to be true. I will increment the current level and set the text content of the game message element to show the current level has been completed. Then I will set the display of the game message element to be block. I will call the set timeout function, passing in the start level function to it, and the delay timer will be 1500 milliseconds. If the bricks remaining is not equal to 0, then I will set game over to be true. I will set the text content of the game message element to be you win. Then I will set the display of the game message element to be block. I will check if the y component of the position of the ball is greater than the height of the canvas. Then I will set game over to be true. The game message element dot text content will be equal to game over. Then I will set the display of the game message element to be block. I will add the game loop function, and inside this function I will call cts.clearRect to draw the canvas environment. Then I will add a variable dt which is equal to 16 over 1000, so we can get a smooth 60 frames per second animation. Then I will check if launch requested is true and set the y component of the velocity of the ball to be equal to minus 250. I will set the s component of the velocity of the ball to equal 100. Then I will set game running to true and launch requested will be false. I will check if game running is true, and then I will call the word update function with the t. I will call the check win loss function. Else, if the game over is false, I will set the s component of the position of the ball to be equal to the s component of the position of the paddle. Then I will loop through the bodies in the word.bodies array, and for each body I will call the body.draw method, passing in the ctx as an argument to it. Then I will call the request animation frame function with the game loop function as an argument to it. I will go outside the function frame and I will call the request animation frame function again with the game loop function as an argument to it. If I open up the browser, you can see the bricks above and our paddle under them. Now, anytime I move the mouse, you can see that the paddle moves with the cursor, but we have a slight bug because the ball is not showing. This is because we forgot to set the radius of the ball when creating it. So let me go back to the code to sort that out. And now you can see the ball on top of the paddle, and I'm going to launch it, and now just hang around and watch me play this game that we have built.